Okay, so today, what should we do? So this is my plan. We are going to have an R session, and I'm going to show you how to do the t-test, okay, in R. So please log in to the computer. Okay, so we have hourly wages explained by education, gender, and age, right? So let's run a regression with all the variables. But this time, let me save it to like something. So M, this object gets the regression outcome, right? So when you type the variable, it shows the coefficient for the age, female dummy and bachelor dummy, right? Now t-test is here. So it says summary of the regression outcome. This is how I typed it. So I use the summary function. Okay, so inside of the summary function, you put the regression outcome. So this is one way, or you can just run the regression and put everything inside of summary. So this works too. So you have these three variables and the intercept, right? So what is this? Estimate. So that's beta hat. And you know how to use them, right? How to use 0.58 as the age coefficient, and how to use minus 3.6 the female coefficient. Now what is the standard error? That's the standard error. Do you remember that I wrote down some complicated formula on the blackboard yesterday? The square root of something, right? So I'll calculate that thing. So that's the standard error. That's the second line, second column. So it's the third column. P-value. Is the t-value. Okay, so that's the value of the t, statistics. What is the last column? That's the p-value that you know, right? Okay, let's take it as an example. So p-value is 16. So what does it mean? Now the null hypothesis says that the coefficient for age is 0. The alternative says that it is not. Okay, under the null, age does not change anything about the weekly wages, right? So in some sense, it's not relevant. It's not important. Do you reject it or not? Why? Because t-value is bigger than 2. So you reject the null hypothesis. And you conclude that age matters. In either direction, it matters. Okay? Now this is the gender dummy. Female gets 1. T-value is minus 17. Again, the hypothesis is coefficient on the female is 0. It is not important to explain variations in income. Do you reject the null hypothesis or not? It's not bigger than 2. Do you reject it? So when do you reject the null hypothesis in a t-test? When t-value is too big, bigger than 2, or too small, less than minus 2. Right? So that's the conclusion. So you reject. Okay? So gender matters. So gender causes variations in weekly wages. Education, the college graduate gets 1. The t-value is 38. The hypothesis is college doesn't matter. Do you reject it? Yes. So that's how you use this t-value. What about p-value? They are all extremely small, right? And you reject the null hypothesis that something is not relevant, not important, then p-value is very small, right? Less than what? Less than what? 0.5? 0.05, right? So you reject each of those hypotheses. Now the star means so 1 star means it is significant when alpha is 1%. I think that's how we read it, right? So 2 star means significant when alpha is very small, 0.1%. And 3 star means it's just extremely significant, whatever that means, okay? So that's how we use this table. Now, we know a lot about these tables, by the way. Now we know how to use everything over here to do t-test. And then we know that this is the SAR. It shows the average size of your prediction error. And this is the R squared. So what is left is only a few things. So we need to know when to use the adjusted R squared. And we need to know what's the meaning of this F statistics, right? We are very close. Do you have any questions about this? Is everything okay? By the way, what I just did is a part of this reading guide, day 14. So it's up there. I just made it available maybe 30 minutes ago. I just made it. And we are going to do more about this R comment, but it's explained in the second page of day 14 reading guide. So if you want, you can read it. Oh, let's think about the confidence interval. We got to do that too. Do you remember this from yesterday? So that's a 95% confidence interval, the slope parameter, or the intercept, the regression problem. So it's centered at beta hat. It can be beta 1, it can be beta 2, it can be anything. Plus minus, so you go to the right and left. 1.97, approximately 2 times standard error of that beta hat. Now we know the estimate and standard error, right? So we can construct the confidence interval. So let's do that. So can you imagine that you construct a confidence interval for the age coefficient? Let's call it beta 1. Okay? So what's the 95% confidence interval for age coefficient? So it is centered at the estimate. Plus minus, you go about 2, and you multiply the standard error. Okay, so that's the 95% confidence interval. Can you do me a favor? Can you calculate this? And can you give me the left-hand side and right-hand side? So what is this minus 2 times this number? 0.492. So is that the left-hand side? What's the right-hand side? Is it that big? Okay. So that's a 95% confidence interval. We can think about a few things. One is that, does it include 0? It does not, right? Then it means that when alpha is 5%, you can reject the null hypothesis, that age is not important. Okay? So we have like 3 methods. You can use the t-value, or you can use the p-value, or you can use a confidence interval. If a confidence interval does not include 0, the 0 as a hypothesis will be rejected. Okay? Now let me give you an exercise. Now, can you write down the 95% confidence interval for the college degree? Can you do that? It's a part of your problem set. So you need some. So what is a 95% confidence interval for beta 3 for bachelor degree? So approximately 7.6 and 8.4, kind of. Right? It's close enough. Now, suppose that the null hypothesis says the beta for the college degree is 0. Can you reject it with 5% significance level? You can, right? Now let me change the question. Now the null says beta for the bachelor degree is 8.2. Can you reject it? No, this time you don't want to do it. Okay? So that's how you use a confidence as a method for testing. Is it clear? Okay, so then I believe that you are really ready to do the assignment. Okay, so maybe you can try today. Now, what is remaining is the meaning of the confidence interval. This, again, it's been done in the statistics class. So you probably remember this. So a 95% confidence interval basically means, so basically it means that beta is going to be included in this confidence interval with 0.95 probability or frequency. So it's kind of intuitive, right? But the tricky point is this. So approximately this is true, but we got to be careful. I'm not sure whether it's important for us. It is important for the statistics when you learn this thing the first time, but after that, I'm not sure. But let me try it. So the thing is this. This beta is a number. Okay? So there's no randomness. So the thing is, we just don't know its value. What is the effect for college degree for a general population? What's the answer? We don't know, right? So in that sense, it's a number, but we do not know it. But at least there's no randomness. It's just a fixed number. Okay? There's something to remember. But this confidence interval is a random variable because beta hat is a random variable. Why is it random? It can be changed. It can be different when I draw another sample. So in one sample, I have this confidence interval. In a second sample that my friends use, you may have a different confidence interval. In that sense, it's random. You never know which confidence interval you're going to use. So the weird thing is that this is a random variable, and this is a fixed number. So to be precise, a wrong interpretation may be, so naively, if you try to interpret this probability, if you believe that you get a sample and you get a confidence interval, right? Just like what we calculated. right before. And if somebody says that the real coefficient, the real effect of college degree is included in that confidence interval with 95% probability, strictly speaking, that is wrong. Okay? No, sorry. It's not the best, it is not the best explanation. So the thing is, so let me try again. So you collect one sample, then you have a confidence interval, right? So between 7.4 and 8.6. So that's the confidence interval we calculated for the effect of the education. So wrong interpretation is the true effect will be included in this interval with 95% probability. So that's wrong. So why is it so? Because this is a number, and this is a fixed interval, given interval. So there's no 95% probability that this number is included in this interval. It's either in or out. Do you see the point? We just do not know the value. If it happens to be 8.1, it is in. If it is 8.7, it is out. So once you fix your confidence interval, the only meaningful probability is either 0 or 1. 0.95 doesn't exist. You have it or not. Okay? So in that sense, the wrong interpretation. Does it make sense? Again, this is a number, and this is a number. So there's no chance that, sometimes it is in, sometimes it is out. It's just impossible, strictly speaking. Now, what's the meaning of this probability then? So again, this is a fixed number, but this is a random variable. So you have to think about the situation where this random variable takes different value. Okay? So the official interpretation of a confidence interval is something like this. Now you collect your sample many times, not just once, but 100 times. Each time you're going to have a different confidence interval because you're going to have a different beta hat and different standard error. Okay? And sometimes you get the true effect inside, and sometimes you don't. So what's the frequency that you get the true effect inside of your confidence interval if you repeat this many times? So that's approximately 95 times out of 100. Okay? So again, it's kind of a little point, but the randomness is coming from here, not from here. Okay, so that's something you learned in your statistics class. Do you remember that there's a wrong interpretation and there's a correct interpretation? Confidence interval? That's what it means. Okay. Now, let's move on. There's only one topic left in this reading guide. And let me just finish it. Now, the effect is your concern. This is the confidence interval. Okay? This is how you get the confidence interval. But sometimes we're actually not interested in the effect. We're actually interested in the changes in the dependent variable if you do something. Okay? This is what I mean. Sure, this is one of the main points of running the regression, right? If you run the regression, you have an estimate for the effect. And this is something you can control. Right? You want to increase your class size or you want to decrease your class size. Then what you really want to know is the changes in the dependent variable, the average change in dependent variable. Right? So what's the confidence interval? This is kind of prediction. And the point prediction is often wrong, actually always wrong. So what if you want to make an interval prediction, something like that? So what's the confidence interval for this guy, the changes in y? A 95%. Because sometimes, suppose that you're a consultant and you have customers out there. That's what your customers wants to know. So that's the number you have to report. Okay? It's actually quite easy. This is just a fixed number. You can increase, decrease your x any way you want. So there's no randomness here. All the uncertainty is coming from here, right? So it's kind of an easy exercise. You have a random variable times a constant. So the confidence interval for the changes in y is a 95% confidence interval for beta times changes in x. So that's the confidence interval you're going to report to your customer. So this is something you already know. So suppose that your dependent variable is hourly wages, and your independent variable is a dummy variable. So two examples we already have is you have a college dummy, or you have a female dummy, right? A dummy variable means a variable that takes only two kinds, one or the other. Then the regression model so the thing is that we usually use xi for the independent variable, right? But when the independent variable is a dummy variable, the convention is we like to use d. It stands for the dummy instead of xi. So this is your regression model. Okay. Now the question is, what is the meaning of beta 1 and what is the meaning of beta null, the intercept? Do you remember these three regression assumptions? The first one is the most important, right? The expected value, the average value of the error given independent variable must be equal to 0, right? Now the xi we have is di. And we know that roughly it means that your error and your independent variables are uncorrelated, right? At least uncorrelated. It's more than that, but it has to be uncorrelated, at least. Now let's remember that, and let's take the expected value on both sides. But I want to take the conditional expectation. So conditioned on that you know the gender. If I use the second example, what is their mean wages? Or if I use the first example, conditioned on that you know that he or she has a college degree, what's the mean wages? That's the question we ask. Now for the expected value, all the constants can go out. Actually, so is it okay? The y beta null goes outside because it's a constant. Same for beta 1, it just goes outside the expected value. So why is it so? The regression assumption. The assumption says that this has to be 0. Otherwise, we don't trust regression. Is it okay? Now, what's the mean of di? If you know the value of di, which is di, right? Now, let me ask this. What is the mean wages if the subject has a college degree? That means that we use 1 for di, okay? So di takes 1. So you put 1 for the di, and by the way, the conditional mean is here. So it's going to be beta null plus beta 1 times 1, right? di takes 1. Now, what is the mean wages of high school graduates? And di is 0. So I use the expression, but di is 0. So the second term disappears. So here comes the interpretation of beta 1. So if you subtract them, so the beta 1, the slope, is the difference in two average wages, right? So average wages of college graduate minus average wages of high school graduate. So basically it says, if we pick a person and make this person get a college degree, then you can expect that on average, because different thing happens for different people, on average, his or her income goes up by this much. And we view that as the effects of a college education. Okay? So that's beta 1. Now, what is beta null? Beta null is the average wages of high school graduates. Okay? And if you sum them up, you get the average wages of college graduates. Why? Because beta null gives you the average wages of high school graduates. Right? The group that goes against you. And beta 1 is the difference between two groups. So if you sum them up, you have the average wages for the new group. Okay? So these interpretations are very important. Now, let me give you a few exercises. Now, suppose that yi is the test score, and di gets 1 if the school is in a big city, and 0 otherwise. Okay? So we are talking about the effects of being in a big city, like so. What's the meaning of beta 1? That's the average test scores in a big city minus average test scores in a place that is not in a big city, some rural area, right? So that's the big difference in two means, to mean it, to average test scores. city minus rural area. Now what is beta null in this example? Test score, average test scores in the rural area. So how do you get the average test scores for the big city? Sum them up. Intercept plus slope. Okay? So that's how you use it. So that's when you have two groups. What if you have three groups? Now think about this. When you have two groups like male and female, how many dummy variables do you need? You just need one variable, right? That variable gets 1 or 0 depending on. Suppose you have three groups. How many variables are you going to need? Suppose that you're comparing the ROA of different companies and you have three categories. Big corporations and medium size and small. So how many variables do you need? You need two dummy variables. Maybe you have D1 that gets 1 for every big companies and 0 for otherwise. And you have D2 that gets 1 for every medium-sized companies and 0 for otherwise. You don't need 3, right? Now suppose that you have a regression like this. So you have two dummies, so you can use them in your regression. Now, can you imagine the meaning of intercept and beta 1 and beta 2? Can you imagine it? You don't have to answer it now. Just think about it, okay? Using the intuition you have. So Y is the ROA, return on assets. Now let's review this slightly. What is the meaning of the intercept, beta null? In this example, that's the mean wages of high school graduates. And that's the group, by the way, you didn't assign any ones. That's the group of 0. That's the group that you didn't give any attention. Okay? That's the intercept. Now, what's going to be the meaning of this beta null here? That's the mean ROA for small companies. Does it make sense? So, in some sense, we use these small companies as our baseline. So it's like a two-step. So in this example, we calculate the average wages of high school graduate first. Okay, that's the intercept, beta null. And then we calculate the gap between the college graduates and the high school graduates. So suppose the gap is this much. So you know the baseline, and then you know the difference. So if you add them, it's going to give the average wages of college graduate, right? Because it's college minus high school. So in that sense, high school is the baseline group. So we measure the average ROA for the baseline group. So that's beta null. Now, what's the meaning of beta 1 then? So it will be the difference in two average ROAs, right? But between whom? That's important. So that's the difference between big companies and small companies. Big minus small. Okay? So how do you measure the average wages of big companies? So you know the baseline and you know the difference, right? So if you add them, that's the average ROAs of big companies. Okay? Now, what's the meaning of beta 2? Again, it's a gap, it's a difference. Suppose that this is beta 2. What does it mean? So that's the difference between medium-sized companies minus small companies. Okay? It's medium minus small. So how do you get the average ROAs of medium-sized companies? It's here. Is it confusing? Is it okay? So initially, you can be confused, but I'll give you enough exercises. So I'm going to have a quiz about this. So again, to summarize, the beta null provides the average of y for the baseline group. The group never gets 1, and you assign those dummies. So from that baseline, you either go up or down. If beta 1 is positive, it means that the group that gets 1 for this dummy has high averages than baseline. If this is minus, then group gets 1 in this dummy gets lower averages. Okay? Now let me ask the final question. So what is, so listen carefully, the difference between big minus medium size. So what I mean is, what is the difference in ROAs between big companies and medium-sized companies from this regression? So how do you know? So how do you find it out? So this is the average Y for big companies. This is medium-sized companies, so you want to subtract them, right? So the answer is beta 1 minus beta 2. Okay? So that's how you use dummy variables. Now you can easily imagine that you can extend it a lot more. Suppose that there are 8 groups. How do you analyze them? You just need 7 dummy variables plus intercept, and then you can think about the meaning, and you can basically get to know everything that you need to know. Okay? Okay, in the reading guide, there's some discussions about what's the meaning of beta hat then. So you can read it. Also, there's discussion about t-value. Let me just mention it very briefly. So again, suppose that you want to compare 2 groups, whatever that is, group 1 and group 0. So in our example, this is college graduate. This is high school graduate. And you want to compare their mean wages, right? And you like to know the difference, and you like to know how significant the difference is statistically. So in statistics, what we did is use a t-test. Do you remember the t-test in statistics? So this is a t-test to compare two groups. So it's one of the last topic you do in statistics. Now that's one way. Another way is to run a regression. With a dummy variable. Okay? Then you're going to have your estimate. So beta 1 hat gives you the difference between two groups. And if you want to know how significant the difference is, you can calculate t-value, which is basically the ratio of these two things, right? Something we did, and I produce this and that too. Now you have two methods. In statistics, there is a t-test. Now once you learn the regression, you can run this simple regression. So the question is, do they always produce the same answer? Right? Something we have to ask. We have two tools, two things we can play with. If they disagree, then we're in trouble, right? Somebody says, if I use a t-test from statistics, I get something. But if I use regression, I get something else, then we are in trouble. But fortunately, they are exactly the same. So you get exactly the same effect and exactly the same t-statistics. So the conclusion must be the same all the time. Otherwise, there's a mistake somewhere. So that's what is explained in the textbook. So if you want to know more, then please read the textbook. Okay. So let me finish. So for some of you, the next Tuesday is the deadline for the new assignments, but normally it's Wednesday. And as I said, if you have questions, please come and see me right now, or maybe you can come to my office too.